Alright, today we're going to be looking at 9-1 homework. This is inverse functions. Before we jump in, I wanted to kind of go through the textbook, just to kind of remind you guys that you want to spend some time going through the textbook, looking at the definitions, as I'm mainly making videos and showing you how to solve the problems. So 9-1 is doing inverse functions. I'm going to kind of skim this really quickly and then we're going to jump in. So it talks about how to identify one-to-one functions. It shows you with ordered pairs, okay, and explains what one-to-one functions are. Basically, it's a relationship that pairs each x with exactly one y. Okay, you can kind of see this. Gives you the mathematical definition. Says if a and b are not equal, then the y values are not equal. So that means each, if they are, then they're the same. So each one x value is going to be paired with one y value. You can verify this with graphs. Okay, if either x value or y value repeats, it is not one-to-one. We can check again with graphs. There's a horizontal line and a vertical line test. I'm kind of just skipping through. If a horizontal line crosses the graph more than once, it is not one-to-one. If a vertical line crosses more than once, it's not one-to-one. So this one would be one-to-one. Vertical line crosses more than once, it's not one-to-one. So you have those two tests, horizontal and vertical. Then we get down to talking about two functions being inverses of each other. Now in the prep, we did do some composition of functions. So inverses, you're going to plug one function into the other, and if the solution just ends up being x, then they are inverses. Here's that mathematical definition. And again, it shows you just a mathematical formulation of what's going on. Some examples that they provide for you. How to find the inverse. Here are the step-by-step procedures. Y and f of x are the same thing. So if you're given f of x, replace it with y first, and then you're going to switch x and y. Every time you have a y, replace it with x and vice versa. Then you're going to solve for y, which we also saw that in the prep section. And then once you have solved for y, replace that y with f inverse, f negative 1. So that's not a negative 1, that's an exponent, but that's just a symbol for f inverse. So all of this I'm going to show you when we get into the Aleks homework. I think there's one more topic that they mentioned, and it talks about when do you find the inverse. So you want to find the inverse whenever it is one-to-one. So after this is just a bunch of practice exercises. So anyway, just remember you do have this textbook, a lot of good information there. Let's jump into it. So here's problem number 1. It says a relation in x and y is given. We're going to determine if the relation is one-to-one. So I'm going to look at each of the x values, make sure nothing repeats. So we got a negative 14, we have a 5, we have a negative 3, we have a negative 1. So no x values repeats. Same thing with the y. So I have a negative 3, have a negative 3. So this violates the one-to-one. So I have two y values that repeat. It would be a function. Okay, so it could be a function if the x doesn't repeat. But if it's one-to-one function, that means the x can't repeat, nor can the y. So the relation does not define y as a one-to-one function of x. All right, we have the same question. We just have a dot plot, so a scatter plot, if you will. If I draw a vertical line, it only crosses each dot once. Same thing if I was doing horizontal. No horizontal line would hit more than one dot. No vertical line would hit more than one dot. So this does define y as a one-to-one function of x.